Using the sine law, part 1. So here we are again with this problem, and I'm going to put in the labeling we had decided in the last skill, and we are wanting to find sine b. And we know that one way to figure out whether or not the sine law is an appropriate law to use is if we have the angle and the opposite side, that combination, that tells us the sine law is the best way to solve this. So we have the sine of A over little a equals the sine of B over little b. Now before I place numbers in here, I just want you to identify that this is the number, this is the variable we're looking for, and notice it's in the denominator, and that's always a harder place for the variable to be that if we're isolating it. So I want to make the problem a little bit easier, and the sine law can be written this way, or you can take the reciprocal of both sides and end up with A over sine A equals B over sine B. That means that the b that I'm looking for is in the numerator and easier to solve. So now I'm going to plug in my values. Little a is 265. Sine, the angle A is 48 degrees. B is the one we don't know, and sine B is the sine of 59 degrees. So if I want to get B all by itself, all I need to do is multiply both sides by the sine of 59. It will cancel on this side and show up on the other side. Now, using your calculator, evaluate this, and you should get B equals 305.7 meters. Always double check to see if that makes sense with the diagram. So if this is 265, this sure does look like a little bit longer than 265. So 305.7 makes sense. Now it doesn't say how much to round this, but I'm just going to assume to the nearest meter, and that would be 306 meters. So here we've got another applied problem where we've got the water tower, a ranger's tower, and a fire that's being spotted. So I'm going to put in some letters here to help us talk about this problem mathematically. And I'm going to put D, E, and F. Notice I'm deliberately changing the letters just to give you practice on how that works. So this is side F, this will be side little d, and this side will be little e. Now what are we asking for? We're asking for the distance between the ranger's tower and the water tower. So that is F. So we are finding F. We can't use Pythagoras because we haven't got a 90-degree triangle. So we're going to use the cosine law, which on your formula sheet will be given like this. All right, but I have DEs and Fs. So let's see what I can use in this problem. I definitely want to use a D because I know D and I know its opposite side. So I'm going to use D. So sine D over D. And now I need another ratio. I do know angle E, but I don't know its opposite side, and I really don't care. I don't care about that distance. I want angle F, but I don't have this angle. Oh, wait a minute, I do. It's 180 degrees in a triangle, so 180 minus 97 minus 34 gives me an angle of 49 degrees. So this angle is 49 degrees. So now I know angle F, so I'm going to use F, because I definitely want to find out what F is. Now I'm going to rewrite this so that the F is in the numerator. So it will be D sine D equals F over sine F. Now plugging in our numbers, D is 150, sine of 34 equals little f, which we don't know, over the sine of 49. Just like in the last problem, we're going to multiply both sides by sine 49. And this will cancel, and I end up with F equals 202.4. So I'm just going to round it to the nearest foot, which is 202 feet. And then I double check, does that make sense for this diagram? Yes, it looks like it's a little bit longer than 150, so that seems it's reasonable. Now the last question is, what are you assuming when you're doing this calculation? One thing you're assuming is that it's all at the height is the same. So that we're talking about not too, the terrain isn't too hilly, so it's fairly flat in order for this calculation to work. We're also ignoring the height of the towers because this is obviously on the ground, but the height of the towers makes a difference. So those little details are not included in the calculation.